Hello, welcome to Maths Marathon classes. This time 2023 JEE Main limits PYQs. So January and April shift. Totally there are 12 questions asked altogether from this topic, including January and April shift. We'll discuss one by one. We've done so far limits synopsis completely for various competitive exams. Very helpful with examples I've done. And then I've started doing the PYQs of 2019 JEE Mains. 2020, 21, 2022, now we are at 2023. Still many more videos I'll be doing, 2024, then 2025, then we'll go to another topic, continuity, likewise continue further and further. All the topics will cover one by one, okay. Take the first question. Let A1, A2, A3 be n positive consecutive terms. A1, A2, A3, etc. be n positive consecutive terms of an arithmetic progression. D greater than 0 is its common difference. You have to find limit n tends to infinity, root of d by n multiplied by 1 by root A1 plus root A2 plus 1 by root A2 plus root A3 plus and so on. 1 by root an minus 1 plus root an is equal to how much? Various options are given. Question asked on 6th of April 1st shift 2023. So A1, A2, A3 etc. are in arithmetic progression. We know arithmetic progression means the difference between the two consecutive terms is constant. Can I write, since the terms are in AP, I can write A2 minus A1 is equal to A3 minus A2. Difference between the two consecutive terms is constant. An minus 1, correct, is equal to common difference D, correct. D is the common difference. Because the terms are in AP, we know the difference between the two consecutive terms. Second term minus first term, same as third term minus second term, etc. is equal to nth term minus n minus 1 term. All are equal to the common difference D. So what we'll do is we'll simplify this bracket, terms inside the bracket. What we'll do is we multiply and divide by root A2 minus root A1 for the first term inside the bracket. Okay, we know that root A1 plus root A2 is same as root A2 plus root A1, right? So that will use, and simultaneously I'll multiply and divide by root A2 minus root A1. In doing that, in the denominator, I can use the formula a plus b into a minus b, which is a square minus b square. It becomes root A2 plus root A1 into root A2 minus root A1, which is A2 minus A1, which is the common difference D. Likewise, in the second term, what I am going to do is multiply and divide by root A3 minus root A2. Denominator will be a plus b into a minus b form, which is a square minus b square, correct, root A3 plus root A2 into root A3 minus root A2. That will be A3 minus A2, which is again the common difference. I am trying to make the denominator same everywhere. I can make the denominator same as the common difference D everywhere inside the bracket, all the terms. So that is the purpose of multiplying and dividing by root A2 minus root A1 for the first term. For second term, multiply and divide by root A3 minus root A2. And for the last term, multiply and divide by root An minus root An minus 1. Let's simplify it. And also we use the concept of limit n tends to infinity. N tends to infinity means 1 by n tends to 0. I'll be using that concept to evaluate this limit. Okay. So limit n tends to infinity, the given expression, limit n tends to infinity, that's given to us, root of d by n inside the bracket now, multiplying and dividing by root A2 minus root A1. Denominator will be root A1 plus root A2 is same as root A2 plus root A1, right? I'll show the steps in detail. Root A2 plus root A1. Of course, we can do this problem within a minute. While explaining, it takes more time. Okay, doesn't mean that I'm slow, because I'm explaining and doing it. It is taking more time. Of course, we can do it in lesser time. Root A3 minus root A2 divided by, denominator will be root A3 plus root A2 into root A3 minus root A2, correct? And continuing like this, the last term will be, I am multiplying and dividing by root an minus 1 divided by what we have, root an plus root an minus 1 into root an minus 1. And this will be what? A plus b into a minus b form, which is a square minus b square. What I get here? Denominator will be a2 minus a1. a2 minus a1, which is the common difference d. This also, if you multiply a plus b into a minus b form, a square minus b square, it will be equal to what? a3 minus a2, which is also the common difference d as given earlier. Here also, same story. A plus b into a minus b, a square minus b square, that will be equal to an minus 1, which is equal to the common difference d. So in all the terms, denominator is going to be the common difference d. So I can take 1 by d outside. Correct? This is equal to limit n tends to infinity, root of d by n. I can write it as root d divided by root n, and denominator is d everywhere. Correct? Each term. This is d. Here also d. Here also d. Each term inside the bracket, denominator is d. That means 1 by d can be factored out. 1 by d is out. Correct? And the first term in the numerator here is root a2 minus root a1. Correct? Next term will be root a3 minus root a2. Next term will be root a4 minus root a3. If you want to write one more term there, root a4 minus root a3. Like this it goes on. Last term is root an minus 1. See, inside this bracket, many of the terms are cancelling. Only at last, only 2 terms will remain, right? Can you identify that? Root a2 is going to cancel. Here, root a3 is cancelling. What is last but one term? Root an minus 1 minus root an minus 2. Root an minus 1 cancels. So what is left out is only 2 terms are not cancelling. That is root an minus root a1. I'm getting like this. So, and also I can write this d as a root d into root d. So one root d is going to cancel, right? So I'll write here the remaining part. I can write here itself. That is equal to limit n tends to infinity. Root d is root d into root d. So one root d cancels. So one root d remains. What is left is 1 by root n into root d. Hope you understand. D is root d into root d. One root d has been cancelled. One root d remains in the denominator. What is left inside the bracket is root an minus root a1. And an is what? An is nth term. Nth term formula we know. Correct? First term plus n minus 1 into common difference. I'll write simultaneously for that. Root of an. An is a1 plus n minus 1 into common difference. Correct? Minus root of a1. So much is left. Because n tends to infinity, 1 by n tends to 0. What I'll do is this root n I'll send inside. 1 by root n I'll multiply inside the bracket. What we get in that case? That's equal to limit n tends to infinity. Limit n tends to infinity. 1 by root d, that to keep outside only. This 1 by root n multiply inside. So what I'll get is root of a1 divided by n plus n minus 1 into d divided by n. Root n, that is 1 by root n, is multiplied to the first term and it is taken inside the root. And I divide individually for both the terms inside the root. Minus root a1 by root n, that is root of a1 divided by n. Like this we get. Correct? Now I'll use the concept that as n tends to infinity, so a1 is some number, correct? A1 is some finite number divided by infinity. Something by infinity is 0. In other words, n tends to infinity, 1 by n tends to 0. Infinity is 0 is gone. Here also it becomes 0. A1 by infinity is 0. These two terms are gone. This is 0. This is 0. And here you see inside this root of n minus 1 d by n. N tends to infinity, no? So numerator and denominator both have same degree, correct? The power of n is 1. The highest power of n is 1 inside the bracket, inside the root, in the numerator. Denominator also, the highest power of n is 1. That means degree of numerator equal to degree of denominator. In that case, we know the limiting value is the ratio of the leading coefficient. What is the coefficient of n in the numerator? D. What is coefficient of n denominator? 1. So this will be root d, correct, because root is there already. So I'll write the answer here, last part. So what is left is, now at this stage I'm applying the limit n tends to infinity. For this, 1 by root d is a constant. 1 by root d is a constant. So what is left out is root of 0, because a1 by infinity is 0. N minus 1 d by n, as n tends to infinity becomes d there, correct? Because coefficient of n is d here in the numerator, coefficient of n in the denominator is 1, correct? Minus, this is becoming 0, root 0. Finally, I get 1 by root d into root d, that is equal to 1. Required answer is 1. Simple question using the concept of AP, and also we are using the concept of limit as n tends to infinity, 1 by n tends to 0, and degree of numerator equal to degree of denominator, ratio of the leading coefficient, means the coefficient of highest power of n in the numerator by the coefficient of highest power of n in the denominator. Coefficient of n in the numerator is d, coefficient of n in the denominator is 1, so d by 1 d, this part is becoming 0, this is also becoming 0, root of 0 plus d minus root of 0, and this is 0, and root d into 1 by root d is 1, so required answer is option C. Hope you understand this. Solution is also given to you, the detailed solution is given to you here. Also it will be sent in the group, okay, WhatsApp group, and also will be uploaded in the YouTube. Video solution is also available in the PDF format. Also the solutions are available, okay, all the detailed solution will be available, will be uploaded in the YouTube. Also video solution is also available for each and every question. Hope I understood this. Move on to the second one. Limit n tends to infinity. The question asked on 6th of April, second shift 2023, limit n tends to infinity, 2 power half minus 2 power 1 by 3 multiplied by 2 power half minus 2 power 1 by 5 and so on, 2 power half minus 2 power 1 by 2n plus 1. So look at the pattern first, understand the pattern, each bracket, how it is given, and generalize it, then you can apply limit. This problem we cannot evaluate it so easily by the known methods, correct? So if you are not able to evaluate the given limit by known methods, then normally we go into sandwich this expression between two other expressions. This expression is going to be sandwiched between other two expressions. So whose limiting value will be known to us? We are able to find the limiting value for those two expressions. And if those two expression limiting value are same, and the one which is sandwiched, no, that is also will have the same value as that of the extreme ones. Okay, so that is the idea. So that means I'm going to use the sandwich theorem. Sandwich theorem questions are rarely found. Okay, so many times questions are asked in JEE exam, minimum 3 or 4 times questions have been appeared in JEE exams on sandwich theorem, but quite less compared to series expansion, 1 to the power infinity, L'Hopital's rule, Newton-Leibniz formula. Those are frequently asked, okay, on limits chapter. And please subscribe to my channel, because at some stage we may go live also. So I've been seeing the data actually. Many of them are watching my videos and not subscribing my channel and not giving many likes. If you give more likes, then I'll get the confidence. Okay, you should promote me, should support me actually, because I'm a new YouTuber actually. I have a lot of experience, you can trust me. I'll be doing all the PYQs of all the chapters, but time is required. One day or one night we can't finish off all the topics, right? So those are watching, please subscribe to my channel, support me, give likes, so that even my confidence level will go high. Okay, so please follow my words and come back to the second question. Limit n tends to infinity. The first bracket is 2 power half minus 2 power 1 by 3. Second bracket 2 power half minus 2 power 1 by 5. Third bracket will be 2 power half minus 2 power 1 by 7. Last bracket is 2 power half minus 2 power 1 by 2n plus 1. You see that 2 power half is present in all the brackets, and the second term of each bracket is what? 2 power 1 by 3. 2 power 1 by 5. The powers are 1 by odd numbers, correct? 1 by 3. Second term I'm telling, in each bracket the second term, 2 to the power 1 by 3, 2 to the power 1 by 5, 2 to the power 1 by 7, 2 to the power 1 by 9, like that. And 2 power 1 by 2n plus 1. 2n plus 1 is the nth term when starting with 3, 5, 7, etc. Correct? It's a nth odd number if you're starting from 3. If you're starting from 1, nth odd number is 2n minus 1. All those things we'll discuss in detail in sequence and series chapter. Okay. If you're starting from 1, 1, 3, 5, 7, nth odd number is 2n minus 1. If you're starting from 3, 3, 5, 7, nth odd number is going to be 2n plus 1. So in each bracket you see that there is 2 power half. That's an important observation. And 2 power half is nothing but root 2. Correct? Root 2. 2 power 1 by 3 is cube root of 2. Cube root of 2 is definitely smaller. Correct? Root 2 is 1.4. Cube root of 2 is smaller. And fifth root of 2 is still smaller. Correct? So likewise, I can observe the pattern. I'll make a note of this. 2 power half. 2 power half it will be greatest. Correct? 2 power half is going to be the greatest. And 2 power 1 by 3 is still smaller. 2 power 1 by 3 is still smaller. 2 power 1 by 5 is still smaller. Like this it goes on. 2 power 1 by 2n plus 1. In this order we have. Correct? 2 power half is greatest among all these things. Correct? So that means if you compare 2 power half minus 2 power 1 by 3, which is bigger? 2 power half minus 2 power 1 by 3 is bigger, or 2 power half minus 2 power 1 by 5 is bigger? Definitely I can tell 2 power half minus 2 power 1 by 5 is bigger. Correct? Because we are subtracting smaller quantity. Correct? 2 power half is present in all the brackets. You can treat it as a constant. Okay, some fixed number. So 2 power 1 by 3 is going to be greater than 2 power 1 by 5. That means you're subtracting a larger quantity from 2 power half. You're subtracting smaller quantity here from 2 power half. Next bracket will be you're subtracting still smaller number from 2 power half. That means I can tell you that 2 power half minus 2 power 1 by 3 is going to be less than 2 power half minus 2 power 1 by 5. Correct? Because 2 power 1 by 3 and 2 power 1 by 5 we compare, 2 power 1 by 3 is bigger. You're subtracting a larger quantity from 2 power half, and here you're subtracting smaller quantity from 2 power half. That means this is bigger than this. Correct? Suppose you're writing 100 marks exam, you subtract 5. You subtract 10, which is bigger? 100 minus 5 is bigger, or 100 minus 10 is bigger? Correct? So 100 minus, if you subtract larger quantity, it becomes less. This is like 100 minus 10. This is 100 minus 5, like that. If you subtract larger quantity from a given fixed number, it becomes smaller. If you subtract a smaller quantity from a given fixed number, it becomes larger. Smaller you subtract, the answer is larger if you subtract, I'm telling. And if you subtract larger number, it becomes smaller. Likewise. So 2 power 1 by 3 and 2 power 1 by 5. 2 power 1 by 3 is bigger. 2 power 1 by 5 is smaller. Like that, if you continue, 2 power half minus 2 power 1 by 7, that is still bigger. Because 2 power 1 by 7 is still smaller. Correct? If you compare with 2 power 1 by 5 and 2 power 1 by 7, 2 power 1 by 7 is still smaller. If you subtract a still smaller quantity, this quantity becomes larger. Like that. If we continue like this, what we get is 2 power half minus 2 power 1 by 2n plus 1. Like this I can establish a relationship. Is that clear? Now I am going to sandwich this between the two other expressions whose limiting value can be found easily by the known methods. So that is the idea. Now if we consider this expression, this entire expression, 2 power half minus 2 power 1 by 3, 2 power half minus 2 power 1 by 3 multiplied by 2 power half minus 2 power 1 by 5, like this goes on. 2 power half minus 2 power 1 by 2n plus 1. Correct? This expression I can tell that it is greater than each bracket, no? 2 power half minus 2 power 1 by 3 is, I'll keep as it is once. And this bracket, no, 2 power half minus 2 power 1 by 5, definitely it is greater than 2 power half minus 2 power 1 by 3 as written here. So I'll replace this by, this second bracket I'll replace by 2 power half minus 2 power 1 by 3 and write this side, that is less than. This expression, what I'm writing here, is going to be less than this. So each of this bracket from second onwards till the nth bracket, I am going to replace it by 2 power half minus 2 power 1 by 3. That means 2 power half minus 2 power 1 by 3 present n times. First bracket is 2 power half minus 2 power 1 by 3. Second bracket is 2 power half minus 2 power 1 by 3. correct? Like this it goes on. All the brackets are equal to 2 power half minus 2 power 1 by 3. This product is going to be less than this product, correct? And this product is going to be still less than 2 power half minus 2 power 1 by 2n plus 1. This first bracket I'll replace it by last bracket. Second bracket I'll replace by last bracket because that is bigger. Because 2 power 1 by 2n plus 1 is still smaller. You subtract a small quantity from 2 power half, definitely it becomes larger. So next bracket also 2 power half minus 2 power 1 by 2n plus 1. Like this it goes on. Like this it goes on. 2 power half minus 2 power 1 by 2n plus 1. Correct? That means how many brackets are there here? N brackets, no? This is n times present. So this also present n times. Same thing is present n time. Each bracket is same, no? So I can write it as 2 power half minus 2 power 1 by 2n plus 1 to the power n. So what you get is 2 power half minus 2 power 1 by 3 to the power n is less than. This you keep as it is. Okay? Still not waste much time to write this. 2 power half minus 2 power 1 by 2n plus 1 to the power n. Now take limit on each of this. Applying limit n tends to infinity. Applying n tends to infinity as given there in the question. Apply limit n tends to infinity for this. Limit n tends to infinity of 2 power half minus 2 power 1 by 3. 2 power half minus 2 power 1 by 5. 2 power half minus 2 power 1 by 2n plus 1. Apply limit here also. You realize that 2 power half minus 2 power 1 by 3 is a number between 0 and 1. Any number between 0 and 1 to the power infinity is 0, correct? Already we have that correct result. I'll write the result here. Limit n tends to infinity, correct? R power n is equal to 0. If r lies between 0 and 1, we have, even if r lies between minus 1 and plus 1 also it's possible. Here it's required between 0 and 1. If r lies between 0 and 1, a number is between 0 and 1 to the power infinity is 0. Correct? This number definitely lies between 0 and 1. 2 power half is root 2. 2 power 1 by 3 is cube root of 2. Root 2 minus cube root of 2 will lie between 0 and 1. This lies between 0 and 1. If a number lies between 0 and 1 to the power infinity is going to be 0. Correct? Limiting value of this is 0. Same story here also. Limiting value of this is 0 because this number will lie between 0 and 1. You take a number, say half square 1 by 4, half cube 1 by 8. If you take a number between 0 and 1, you raise it to the higher powers and it becomes still smaller and smaller. It approaches to 0. Say 1 by 2 to the power 500 is very close to 0. 1 by 2 to the power 1 lakh, it is still smaller, very close to 0. That is a concept. If a number lies between 0 and 1 to the power infinity is 0. This is becoming 0. This is becoming 0. This is sandwiched between these two because limiting value of this is 0 and limiting value of this is 0. This limiting value is also 0. Hence, the required answer is 0. By using sandwich theorem, or can also call it as squeeze play theorem. Correct? Hope I understood this. If you are not able to evaluate a limit of a given expression, then we can sandwich that expression to lie between the two extremes one. So that you are able to find the limiting value of this, you are able to find the limiting value of this. Hence we get answer is 0. Hope you understand. Solution is also given to you. Third one. Limit x tends to 0. 1 minus cos square 3x by cos cube 3x multiplied by sin cube 4x by log of 2x plus 1 to the power 5 is equal to how much? Question asked on 8th of April 1st shift 2023. Can you do this? First of all, I can use trigonometric identity there. 1 minus cos square theta is sin square theta. Correct? Trigonometry functions are present here. And for denominator, you can apply the limit directly. Cos cube 3x, I can apply the limit. If you apply limit directly, not become 0 by 0 form. If you want, you can check. Applying L'Hopital's rule is not so helpful here. We'll get the answer immediately without using the L'Hopital's rule. For denominator, I can apply limit directly. I can write this as limit x tends to 0, 1 by cos cube of 3x, 1 by cos cube of 3x into limit x tends to 0, limit of the product is the product of the limits we know, 1 minus cos square 3x, I'll write sin square 3x, okay, 1 minus cos square theta is sin square theta, no, multiplied by sin cube of 4x, correct, divided by log of 2x plus 1 to the power 5, log of 2x plus 1 whole to the power 5 is given like this. I can apply limit for this. Put x equal to 0 directly here. 3 into 0 is 0. Cos 0, 1. 1 cube is 1. 1 by 1. This part is becoming 1 as x approaches to 0. And here you see the sum of the powers of sine in the numerator. Power of sine is 2. Here power of sine is 3. 2 plus 3 is 5. What is the power of log? That is also 5. So I can tell the degree is same for this non-polynomial function. Of course they are non-polynomial, correct? Sine and log is present. So power of sum of the powers of sine function, the numerator is 2 plus 3, 5, as same as the power of log in the denominator. So directly I can evaluate this without using any theorems. So using my shortcut method already explained in the synopsis, somewhat like this given. So I can write the limiting value of this as 3 square 4 cube. Look at the coefficients. Coefficient of x is 3, so 3 square. Coefficient of x 4, so 4 cube. Divided by, what is coefficient of x2? 2 power 5. That's it, over. 2 steps answer. 1 by, here 3 into 0, 0, cos 0, 1, 1 cube is 1. Into, limiting value of this is 3 square into 4 cube divided by, what is coefficient of x2? 2 power 5. Over, answer. 3 square is 9, correct? 4 cube is 64. 2 power 5 is 32. 32 1s are, 32 2s are, 9 2s are 18. Over, answer. Option D. Can do it within 20 seconds. If you observe carefully, 20 to 30 seconds we can crack this question. Some questions are there of this time. We can do it in lesser time. There are questions. Okay. If you want to do the actual method also, if you're not understood how this shortcut has come, and I can do the actual method. This part you understood, right? Applying limit directly. This part I'll show. This part, only the second part, the second term, I mean the limiting of this trigonometric and log function. What I'll do is limit x tends to 0. If I want, I'll do it in detail. Sin square 3x means what? Sin square theta means sin theta into sin theta. So sin square 3x means sin 3x into sin 3x. Sin 3x into sin 3x. Correct? Divide by 3x. Divide by 3x. Sin cube 4x means what? Sin 4x into sin 4x into sin 4x. Correct? Sin 4x. Sin 4x into sin 4x 3 times. Divide by 4x, divide by 4x, divide by 4x. Correct? Divide by 4x, divide by 4x, divide by 4x. Denominator is what? Log of 2x plus 1 to the power 5. Log of 2x plus 1, you divide by 2x. That means you divide it by 2x to the power 5, no? Because whole power 5 is there. So to balance it, you multiply by 2x power 5. Here also, to balance it, I'll multiply by 3x the whole square into 4x the whole cube. Okay? That I'll show it here itself. Multiply by 3x the whole square into 4x the whole cube. This part is 1. Sine of an angle by same angle is 1. Sine of an angle by same angle is 1. Correct? Everywhere. Even log of 1 plus x by x is 1. There is a theorem, limit h tends to 0, log 1 plus h by h is 1. Instead of h we got 2x. Even as x approaches to 0, 2x approaches to 0. Whatever rounded off is 1. So what is that? Is 3 square into 4 cube. Limiting values, limit x tends to 0. What is left out there? 3 square into 4 cube into x power 5 divided by here 2 power 5 x power 5. X power 5 is going to cancel. This is 4 cube 64. Same thing we got 3 square into 4 cube by 2 power 5. Limiting value. Limit of a constant is constant. We'll get the same answer 18. Hope you understand. Learn this kind of method so that you can save the time, crack the question in lesser time, and you can get the answer easily. Okay. And this is applicable when you see power of sine in the numerator and denominator is same. Because of the theorems, all this happens because limit theorem is there. Limit x tends to 0, sin x by x equal to 1, limit x tends to 0, tan x by x1, and limit x tends to 0, log 1 plus x by x1. Because of that, we are having all these things. If you want, I'll give one more example of this type. Okay, I'll show you the solution here. Solution is given in detail. I'll add one more page here so that I can give an example for you. Suppose I'll ask you a question like this. Limit x tends to 0. Limit x tends to 0. Suppose I give sine cube of 2x into tan to the power 7 of 3x, okay, divided by 3x to the power 6 into sine to the power 4 of 2x, like this. See the powers of sine and tan. What is the numerator? Power of sine 3, power of tan is 7, 7 plus 3 is 10. Denominator is what? 6 plus 4 is 10. Correct? So what we have is, I can write the answer directly by taking the coefficients of x everywhere. What is coefficient of x for sine here? 2. So 2 cube. What is coefficient of x for tan there? An angle 3. So 3 raised to the power 7 divided by here 3 power 6. Correct? Coefficient of x is 3. 3 power 6. Coefficient of x is 2. 2 power 4. Answer is how much? 3 power 6 cancels. 1 3 remains. Here 2 cube is cancels. Answer is 3 by 2. Here I give an example with sine and tan. In synopsis part also I explained this type of question earlier. And I can take up even a question on something which connects with log 1 plus x by x, as we had. Even in terms of e power x also, because of this theorem, limit x tends to 0, e power x minus 1 by x is 1. Even we can have this also, e power x minus 1 by x 1, limit x tends to 0, sin x by x1. Correct? Expressions of this type is present. Sine e power x minus 1, log 1 plus x by x is 1. Correct? Because of these theorems, we can have the time saving result based on this. Log of 1 plus x divided by x equal to 1. I can frame one more question. I can construct a question based on these results. Suppose I give limit x tends to 0. Limit x tends to 0. E power 5x minus 1 the whole square into sine cube of 2x divided by tan square of 3x into log of 1 plus 2x whole cube, like this. Look at the power of e power 5x minus 1. The power is 2. Power of sine is 3. 2 plus 3, 5. Correct? Sum of the powers of e power 5x minus 1 and sine function 2 plus 3. The powers is 5. Sum of the powers in the numerator is 2 plus 3, 5. And in the denominator, power of tan is 2. Power of log 1 plus 2x is 3. 2 plus 3 is 5. So I can apply this. Even I am applying limit x tends to 0, tan x by x equal to 1. I am using all these 4 theorems actually. But without using the theorem, directly you can write the answer as, look at the coefficient of x here. What is coefficient of x? 5. So 5 square. What is coefficient of x? 2. So 2 cube. Correct? 2 cube. Divided by coefficient of x is 3. So 3 square. What is coefficient of x? 2. 2 cube. 2 cube is going to cancel. 5 square 25. 3 square 9. 25 by 9 is the answer. Limiting value. Directly we can answer. Even for NDA and CET exams also these kind of questions can be asked. Okay? Directly you can write. If you're not understanding, you can use all these 4 theorems and get the answer. You'll get the same answer. Hope you understand. Move on to the next one. Question number 4. Alpha greater than beta greater than 0 are the roots of the equation ax square plus bx plus 1 equal to 0. Ax square plus bx plus 1 equal to 0. Roots of this equation are alpha and beta. Alpha and beta are the roots of this equation according to the question. You observe that the quadratic given inside this bracket is not same as this. Here the quadratic expression is x square plus bx plus c. Whereas here it is ax square plus bx plus 1. See, if you observe these two, they can be related to each other. How can they relate? If you replace x by 1 by x, replace x by 1 by x, what we get? A into x becomes 1 by x, 1 by x the whole square, plus b into 1 by x plus 1 equal to 0. Now we multiply the entire equation by x square. What do you get? A plus bx plus x square equal to 0. That is what we have. A plus bx plus x square. So roots of this equation are what? 1 by alpha and 1 by beta. Correct? Because if you replace x by 1 by x, I am getting that. Because alpha and beta are the roots of this equation, I can conclude that roots of this equation are 1 by alpha and 1 by beta, because this equation is got by replacing x by 1 by x. So if alpha is the root of this, 1 by alpha should be root of this. If beta is the root of this, 1 by beta should be root of this. 1 by beta should be root of this. That's an important observation. And because 1 by alpha and 1 by beta are the roots of this equation, x square plus bx plus a, x square plus bx plus a could be written as identically equal to x minus 1 by alpha into x minus 1 by beta. Because 1 by alpha and 1 by beta are the roots of this equation. I can write this quadratic as x minus 1 by alpha into x minus 1 by beta. So now taking this left hand side, limit x tends to 1 by alpha, x tends to 1 by alpha, 1 minus cos of this quadratic expression. Instead of writing x square plus bx plus a, I shall write x minus 1 by alpha into x minus 1 by beta. X minus 1 by alpha into x minus 1 by beta. Correct? Divided by, here denominator you can take alpha common there. 2 into alpha comes out, becomes alpha square into 1 by alpha minus x the whole square, taking alpha out. Correct? Alpha is taken out, even though it's not common, it's taken out. 2 alpha square into 1 by alpha minus x the whole square. And you know 1 by alpha minus x the whole square is same as x minus 1 by alpha the whole square. Whole to the power half is there. Correct? Whole to the power half. This is equal to, I can apply limit inside the bracket. Correct? To the power half means it is square root. I can apply the limit inside the square root. And also I'll write 1 by alpha minus x the whole square is same as x minus 1 by alpha the whole square. Limit is taken inside. Correct? How do you apply limit for a composite function? Likewise, I'm writing it. 1 minus cos of x minus 1 by alpha into x minus 1 by beta divided by 2 into alpha square into, this is x minus 1 by alpha the whole square. Correct? I'll multiply by x minus 1 by beta the whole square too. To balance it, in the numerator also multiply by x minus 1 by beta the whole square. Entire thing to the power half. Correct? What is the advantage of doing this? Because I multiply and divide by x minus 1 by beta the whole square. Now I'm using this, the familiar result we have. Limit theta tends to 0. 1 minus cos theta by theta square is half. I'm using this. 1 minus cos theta by theta square is equal to half. So whatever angle is there, square of that is present here. Correct? So 1 minus, as x tends to 1 by alpha, x minus 1 by alpha is tending to 0, right? The angle is tending to 0, and this part 1 minus cos theta by theta square, this is becoming half. 1 minus cos theta by theta square is half. I'm using this. So whatever angle is present here, square of that should be present in the denominator. As x tends to 1 by alpha, x minus 1 by alpha tends to 0. So 1 minus cos of this angle by square of that is becoming half. So what is left out is, and also I can apply the limit to this. X is approaching 1 by alpha. This becomes 1 by alpha. So what I am getting is, what is rounded off is half. Already 1 by 2 alpha square was there. 1 by 2 alpha square was there. What is rounded off, that is half. Correct? Into x is approaching 1 by alpha. So this becomes 1 by alpha minus 1 by beta the whole square, whole to the power 1 by 2. Correct? Whole to the power 1 by 2 is nothing but square root. See, 1 by 2 into 1 by 2 is 1 by 4. Root of 1 by 4. To the power half means square root. Square root of 1 by 4 is 1 by 2. And square root of alpha square is mod alpha. Mod alpha is alpha because alpha is positive. Alpha square power half. Alpha square to the power half. That is nothing but root of alpha square. Root of alpha square is mod alpha. Mod alpha is alpha because alpha is positive. Correct? Hope you understand. So 1 by 2 alpha. And here 1 by alpha minus 1 by beta the whole square power half. Correct? Square root of. Power half and square root. What we have? 1 by alpha minus 1 by beta the whole square. Square root of x square is mod x, no? So if you take square root of 1 by alpha minus 1 by beta the whole square, don't write it as 1 by alpha minus 1 by beta. It's wrong. Because when you take a square root, answer what you get is non-negative, correct? See, alpha is greater than beta, no? Because alpha is greater than beta, according to the question, I can write 1 by alpha is less than 1 by beta. Correct? So 1 by alpha is less than 1 by beta means 1 by beta is greater than 1 by alpha. That means 1 by beta minus 1 by alpha is positive. Correct? 1 by beta minus 1 by alpha is positive. So when you take square root, when it comes outside, 1 by alpha minus 1 by beta the whole square root of that expression is going to be equal to 1 by beta minus 1 by alpha, because 1 by beta minus 1 by alpha is positive. 1 by alpha is less than 1 by beta. Don't write 1 by alpha minus 1 by beta as the answer for that. You take square root of 1 by alpha minus 1 by beta the whole square is not 1 by alpha minus 1 by beta, because 1 by alpha minus 1 by beta is going to be negative. So what you should write is 1 by beta minus 1 by alpha. That's equal to 1 by 2 alpha into 1 by beta minus 1 by alpha. Then you can compare. Already the given 1 by beta minus 1 by alpha. If you compare k, 1 by k is equal to 1 by 2 alpha. Correct? If you compare, what you get? 1 by k is equal to 1 by 2 alpha. So taking reciprocal, what we get is k is equal to 2 alpha. Option D. Option D is the answer. Hope you understood this. The solution is also given to you here. K is equal to 2 alpha. Option D is the answer. Fifth one, limit n tends to infinity. What we have is statement 1 and statement 2 are given here. Limit n tends to infinity, 1 by n square into statement 1. Limit n tends to infinity, 1 by n square into 2 plus 4 plus 6 etc. You can take 2 common there. Correct? If you take 2 common, what remains is 1 plus 2 plus 3 plus etc. n. Correct? And this is summation of n. Summation of n is what? Sum of the first n natural numbers, n into n plus 1 by 2. Correct? This is equal to limit n tends to infinity. Limit n tends to infinity, 1 by n square into 2. This is summation of n. Summation of n is n into n plus 1 divided by 2. This 2 is going to cancel. And the limiting value is ratio of the leading coefficient. Highest power of n in the numerator is 2. If you multiply it n square, what is coefficient of n square? 1. What is coefficient of n square denominator? 1. 1 by 1 equal to 1. So statement 1 is true. Correct? I am using the concept of limit n tends to infinity. Numerator is polynomial of degree 2. Denominator also polynomial of degree 2. Numerator, denominator have same degree. Correct? Degree means highest power of n. If you multiply it n square here, that's the highest power of n is 2. Denominator also n square. Highest power of n is 2. Both numerator, denominator have same degree. Limiting value is nothing but the coefficient of n square in the numerator by coefficient of n square in the denominator. Coefficient of n square in the numerator is 1. Coefficient of n square in the denominator also 1. So 1 by 1 equal to 1. Statement 1 is true. Statement 2 is actually the concept of limit of sum, which you learn in integration. Actually, they're telling it's a deleted part, but still we should do it, okay? For time being, just understand this, okay? This is not a question on limits actually, statement 2. Statement 1 is of course a question on limits only. Statement 2 is not so. Statement 2, what we have is limit n tends to infinity. What I'm going to write is 1 by n I'll keep outside, and n power 15 is left in the denominator. I'll send it inside. So what you get is 1 by n power 15 plus 2 power 15 by n power 15, because n power 15 is multiplied inside. Okay. So 2 by n power 15 like this continue. 3 by n power 15, denominator n power 15 is multiplied inside to all the terms. Last term will be n by n to the power 15, correct? And this I can generalize it as limit n tends to infinity, limit n tends to infinity 1 by n into summation of r is equal to 1 to 15, correct? There are 15 terms, correct? Sorry, no, n terms, not 15 terms. There are n terms. R is equal to 1 to n. R is equal to 1 to n. R is equal to 1 to n. There are n terms. Generalizing it 1 by n, 2 by n, 3 by n, etc. n by n. So it is r by n to the power 15. Correct? There are n terms. Summation is r is equal to 1 to n. And in general, I can write this r by n to the power 15. If you put r is equal to 1, I get the first term. R is equal to 2, I get the second term. R equal to 3, I get the third term, like that. So 1 by n summation of r equal to 1 to n, r by n power 15. This is nothing but integral from 0 to 1 x power 15 dx. Okay, that we will learn in limit of a sum. In detail, I'll tell you. This is a formula actually. The formula is this: limit n tends to infinity, limit n tends to infinity 1 by n into summation of r is equal to 1 to n function of r by n. If it is function of r by n, then it is integral from 0 to 1 f of x dx. This is the formula. 0 to 1 f of x dx. Integral of x power 15 is x power 16 by 16, correct? Using integral of x power n formula. Limits from 0 to 1. 1 by 16 into 1 power 16 is 1, 0 power 16 is 0. Answer is 1 by 16. So statement 2 is also true. Statement 1 as well as statement 2 both are true. Answer is option D. This is the formula on limit of a sum. Limit n tends to infinity 1 by n summation r is equal to 1 to n function of r by n is integral from 0 to 1 f of x dx. Okay. Option D is the answer. Both the statements are true. Of course, this is a topic. Say statement 2 belongs to the integration actually. Limit of a sum I've included here itself. I'll explain in a still better way when you come to integration chapter. Okay. Solution was given. Next one, question number 6. Limit x tends to 0. We have this expression. Want to find the value of 5a square plus b square is equal to how much? If I apply the limit, it may take 0 by 0 form, but we'll apply the series expansion for e power x cos function and e power minus x. Okay, we'll apply series expansions. And also denominator we can simplify 1 minus cos to x. 1 minus cos to x is 2 sin square x. We know that trigonometric formula. So limit x tends to 0. Limit x tends to 0. Denominator is what? 1 minus cos to x. 2 sin square x, correct? 1 minus cos to x is 2 sin square x. This is e power ax. I can write the series expansion for that. Before that, I'll write denominator, no, multiply and divide by x square, because we can make use of the theorem, correct? Sin x by x1 as x tends to 0. This will become 1 square, 1 into x square. This will become 1. Sin square x by x square becomes 1. Multiplying and dividing by x square in the denominator. Rest part to keep as it is. E power ax minus cos bx. This is a question based on series expansion, correct? Because we need to find the unknowns here. Cx e power minus x divided by 2 is equal to 17. So this part has become 1. Denominator is x square. 2 we can cross multiply. 2 into 17 is 34. Simultaneously, I'll apply the series expansion for e power ax cos bx and e power minus cx actually. E power minus cx. E power minus cx. Apply series expansion for that. To find the unknowns a, b, c, I'm using this technique of series expansion. So already we done this type of question many times, correct? Limit x tends to 0. E power x. What is the series expansion for e power x? E power x we know. 1 plus x square by 2 factorial plus x cube by 3 factorial etc. up to infinity. But for me what is important is only up till x square. depends upon denominator. If denominator is x square, you write the series expansion up till x square terms. X cube and higher power is not required. It becomes 0. Already we done many problems of the series expansion. Questions are asked in 2021 and 22 also many times. Now we are doing 2023 paper, correct? 2019 and 20 no questions were asked on series expansion. I remember 2021 and 2022 questions were asked on series expansion, infinite series expansion or Maclaurin series expansion. The questions were asked many minimum among those two, 2021 and 2022 if we combine, I think 4 to 5 questions minimum there are on series expansion. And this is another one. And here denominator we simplified using trigonometric formula 1 minus cos 2x is 2 sin square x, and in the denominator we multiply and divide by x square. Sin x by x1 as x tends to 0, so 1 square 1. Denominator became 2x square. X square will keep it there only in the denominator, and 2 will cross multiply. 2 into 17 becomes 34. I am writing series expansion for e power x as well as cos bx and e power minus x. I'll write only terms up till x square. Other higher powers will not required because it becomes 0 when you apply the limit. So that is the idea. If denominator is x cube, suppose instead of x square, if you have x cube, then you write the series expansion for whatever they given, e power x, cos bx, the sine, whatever is given, right up till x cube. It depends upon denominator. Remember that, because denominator is x square, I'm writing up till x square. Writing series expansion for e power x, what do you get? 1 plus ax the whole square divided by 2 factorial. Up till x square is enough. Higher terms not required. You can close the bracket. Yeah, minus cos bx. What is cos x series expansion? Cos x is 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial up to infinity. I need only up till x square. So I'll write only the two terms, the first two terms. 1 minus bx the whole square divided by 2 factorial plus next term I won't write. If you want, I'll tell bx power 4 by 4 factorial. I won't write it. I'm not interested because it becomes 0. Close the bracket. Minus cx by 2. Minus cx by 2 into what we have? E power minus cx. E power minus x what? 1 minus x plus x square by 2 factorial minus x cube by 3 factorial up to infinity. Alternate plus minus for e power minus x. So here I'll write 1 minus cx. 1 minus cx. Next term will be plus cx the whole square by 2 factorial. It's not required, because outside there is x, no? Up till here it's enough. X into x will get multiplied by x square, etc. up till infinity. Close the bracket. And denominator is x square. Denominator is x square. Of course 2x square is there. That 2 I'll send to right hand side. 2 into 17 will become 34. 34, correct? Now open the bracket and simplify. Collect the terms with x square, etc. Here constant term is not there. See here if you multiply I get cx by 2. There is no constant term from the third bracket. Here in the first bracket and second bracket it becomes 1 minus 1. Constant term is gone, 0. Correct? 1 minus 1 will become 0. So there is no constant term. Constant term is 0 actually. So that is not required to write. So limit x tends to 0. What I am going to collect is the terms with x. X terms you collect. What do you get? X terms if you're collecting. Here there is no x terms in the second bracket. In the first bracket ax is there. So coefficient of x a there. Here there is, if you multiply minus cx by 2 into 1, I get minus cx by 2. Coefficient of x is minus c by 2 there. So a minus c by 2 I'm getting. I'll divide this by x square individually. All the terms I'll divide by x square. This kind of question we are familiar. We did many questions, minimum 5 questions we have done from 2021 and 2022 paper. Work out all the previous year questions. Previous year questions plays a vital role in preparation of JEE exams. I'll tell again and again. Now we are in the month of May. If you're preparing for January shift, this is the right time to start. We start with limits, one of the most important topic of calculus. After finishing this, I'll go to continuity, then I'll go to differentiability, then methods of differentiation, like that, one by one. Calculus part will cover, then algebra part, then geometry part, like that. All one by one will cover, okay? What we have? X is common. Next, we'll collect the terms of the x square. X square terms we collect. X square is your coefficient of x square is a square by 2 factorial is 2. So a square by 2 here. A square by 2. Correct? Minus into minus is plus. Coefficient of x square how much? B square by 2 here. B square divided by 2. Minus into minus is plus. X square. So coefficient of x square is your c square by 2. Correct? C square divided by 2. Correct? Divided by x square. Next term I am not writing actually, I'll show you if you want. X cube term x cube into whatever, I'm not interested to fill that, least bother, divided by x square plus other terms are 0, close the bracket, that's equal to 34 here. And if you divide, no, here x square is going to cancel, x will remain in the numerator. As x approaches to 0, this is becoming 0, 0 into some finite number is 0. Likewise, here are not written any terms there. All those terms which I didn't write, no, all the terms are becoming 0 because limit x tends to 0 is there. Next term will be x power 4 into something by x square. X power 4 by x square is x square. X square is becoming 0. 0 into that bracket is 0. Likewise, from here all the terms are becoming 0. Okay, only we have this first two terms, and of course here x square is going to cancel. This becomes a constant here. Limit of a constant is constant, and this constant is a limiting value actually that becomes equal to 34. And here I insist the condition that because the limit x tends to 0, denominator is becoming 0, that means limit does not exist here. But limiting value is already given here. It was initially 17, I made it 34 after cross multiplying, correct? So now the coefficient of the, because the denominator is becoming 0, I insist the condition that a minus c by 2 should be equal to 0. We insist the condition that a minus c by 2 should be equal to 0, so that limit is going to exist. And this is the limiting value actually because there is no x term here. It's a constant. Limit of a constant is constant, and from here all the terms are 0. This is going to be the limiting value 34. And if we equate, what do you get? A square plus b square plus c square, whole thing is divided by 2 because 2 is common denominator there, correct, is equal to 34. So what we get? A square plus b square plus c square is equal to 68. 34 into 2 is 68. And I can use, I want to find what? 5a square plus b square. Here a is equal to c by 2, correct? A is equal to c by 2, that means c is 2a. C is 2a, a square you keep as it is, b square you keep as it is. What is c from this? C is 2a, substitute here. C is 2a, 2a the whole square. 2a the whole square is 4a square. 4a square plus a square is 5a square. Therefore, I get 5a square plus b square is equal to 68 over. Correct? 2a the whole square is 4a square. 4a square plus a square is 5a square. 5a square plus b square is 68. We have to find 5a square plus b square, which is equal to 68. Option C is the answer. Hope you understand this based on the series expansion. The detailed solution is also given to you here. Okay, note down this. Anyway, I'll be sending all these things in the PDF format also. Move on to the next one. Limit t tends to 0. The question asked 1 to the power 1 by sine square t plus 2 power 1 by sine square t plus etc. n to the power 1 by sine square t whole power sine square t equal to how much? Various options are given. Question was asked on 24th of January 1st, 2023. Can you do this? Limit t tends to 0. I can write 1 by sine square t as cosecant square t. We know 1 by sine is cosec, correct? Reciprocal of sine is cosec. So I can write it as limit t tends to 0. Limit t tends to 0. What we have? 1 to the power cosecant square t plus 2 to the power cosecant square t etc. n to the power 1 by sine square is cosecant square t whole to the power sine square t, correct? And as t is approaching 0, cosec t will approach infinity. It becomes 1 to the power infinity here, 2 power infinity, etc. And the power of this entire thing is becoming 0. Sine 0 is 0, correct? So it's a quite unusual kind of expression is given here. To evaluate this, what we'll do here, we'll take n power cosecant square t out. Even though it's not common, I'll take common here and balance it by dividing by that term. So this is equal to limit t tends to 0. Limit t tends to 0. What I'm doing here, from these terms, the biggest number is n. If you compare 1, 2, 3, etc., n is biggest. So I'll take that out. N to the power cosecant square t is taken out. So to balance it, you divide by n power cosecant square t for the terms. So this will be what? 1 power cosecant square t by n power cosecant square t, which is 1 by n power cosecant square t. So that when you multiply this and this, I'll get 1 power cosecant square t. Next term will be 2 by n to the power cosecant square t, correct? So that when you multiply this and this, n power cosecant square t is going to cancel. I get 2 power cosecant square t. Likewise, if I continue, last term, because already n power cosecant square t is taken out, it becomes 1. Close the bracket. This entire thing is raised to the power sine square t. Correct? This type of question is found in many of the books. Okay, it's not a new question. It's already found in many of the JEE books. Okay. Now what I'll do is, I'll raise this n power cosecant square t power sine square t. Cosecant square into sine square is 1, right? As t approaches to 0, I can multiply those two. The powers gets multiplied and that becomes n power 1. Correct? That's equal to what I'm doing here. Limit t tends to 0. Limit t tends to 0. N power cosecant square t is raised to the power sine square t. Correct? Then what we have is 1 by n power cosecant square t plus 2 by n to the power cosecant square t. Like that it goes on. Last term is 1. This entire thing is raised to the power sine square t. Like this second, right? Here these two gets multiplied. Cosecant square into sine square is 1. N power 1 is n. It's independent of limit, can keep outside. So n into limit t tends to 0. And these numbers then, no, 1 by n, 2 by n, 3 by n, all those numbers will lie between 0 and 1. If a number lies between 0 and 1, to the power infinity is 0. Cosec 0 is infinity. You can take it as infinity, okay, for working out the problem. What happens? 1 by n is a number less than 1. Say if you're not comfortable, take an example. N is equal to 50. 50 is my last number, okay. 1 by 50 is a number between 0 and 1, right? Any number between 0 and 1 to the power infinity is 0. This is approaching 0. 2 by 50, I take an n as 50. So 2 by 50 is 1 by 25. 1 by 25 is the number between 0 and 1. If a number lies between 0 and 1 to the power infinity is 0. Correct? All the terms are becoming 0. Only last term is left. This is 0. This is 0, 0, 0, 0. Only last term is 1. So I'm getting 0 plus 0 plus dot dot dot. Last term is 1. To the power, here also I can raise it to the power sine square t. T is approaching 0. Sine 0 is 0. 0 square 0. So I'm getting n into 1 to the power 0, which is 1. N into 1 is equal to n. Option C is the answer. Hope you understand this. Similar type of question is there in the books. I've seen it. Instead of limit t tends to 0, the given limit t tends to pi by 2, and it is instead of cosecant square, no, the given secant square. Okay. And outside, instead of sine square, no, the power, outer power, the given cos square. They interchange. Okay. Instead of sine square, the given cos square, 1 by cos square, 1 by cos square everywhere, and outside it is cos square. I can write a question if you want. You can evaluate that also. Limit t tends to pi by 2. Instead of t tends to 0, the given limit t tends to pi by 2. You can try that question. Limit t tends to pi by 2. Limit t tends to pi by 2. What we have? 1 by 1 to the power 1 by cos square t plus 2 to the power 1 by cos square t. Like this, it goes on. Correct? Last term is n to the power 1 by cos square t whole to the power cos square t. You can try this. Instead of sine, it's given as cos, and instead of t tends to 0, it's given as t tends to pi by 2. Take it as a homework. Try this. Similar type of question. Solution is also given here. The detailed solution is given to you. Okay. Move on to the next one. Set of all values of a for which limit x tends to a, greatest integer value of x minus 5 minus greatest integer value of 2x plus 2 equal to 0, where greatest integer value of alpha denotes the greatest integer less than or equal to alpha. You have to find in which interval which interval the value of a lies. In which interval the value of a lies, you have to find out. Limit x tends to a, greatest integer value of x minus 5 minus greatest integer value of 2x plus 2 is equal to 0 is given. How to find out this? How to start this problem? First, I'll be using the property of the greatest integer function. What we know, the property of the greatest integer function. The property of the greatest integer function is, we know this property. Greatest integer value of x plus n is equal to greatest integer value of x plus n for all n belongs to z. Correct? This I'm going to use. You see that minus 5 is an integer, 2 is an integer, right? I'll separate out using this property. Greatest integer value of x plus n is greatest integer value of x plus n for all n belongs to z. First, we'll simplify the given expression, then apply the various cases. A is integer or non-integer, various cases we can discuss. Limit x tends to a. Limit x tends to a. Greatest integer value of x minus 5, I can write it as greatest integer value of x minus 5. Correct? Minus. Greatest integer value of 2x plus 2 is greatest integer value of 2x plus 2. But minus into plus will become minus 2 is equal to 0. Correct? Integral value of 2x plus 2 is integral value of 2x plus 2. Minus into plus minus. Simplify this further. Limit x tends to a. Limit x tends to a. What we have? Integral value of x minus integral value of 2x minus 5 minus 2 is minus 7. Limit of minus 7 is minus 7. Take that side, equal to 7. Now I can take the cases. Also you can verify using options also. That is another part, another method. I'll take cases now. Case 1, if a is an integer. If a is an integer. If a is an integer, what happens? As x is approaching a, integral value of a minus integral value of 2a is equal to 7. And a is an integer, no? So integral value of a is a only. Suppose 10 is an integer, correct? What is integral value of 10? 10 itself. Because a is an integer, greatest integer value of a is a. 2a is also integer. Because a is an integer, 2a is an integer. Integral value of 2a is 2a. Hope you understand. So a minus 2a equal to 7. That is minus a equal to 7. That means a equal to minus 7. I'm getting a equal to minus 7 for case 1. I took a as an integer. I'm getting a as minus 7. If you want, you can apply a equal to minus 7 and evaluate. You'll get the answer as 7 for this. Okay. Now, case 2, I'll take a is a non-integer value. Case 2, I'll take a is a non-integer value. Case 2, if a is a non-integer value, is a non-integer, other than integer, a is a non-integer. In that case, already I applied the limit for that. I'll start from this expression. Let a, because a is a non-integer value, I'll take a is equal to some integral value I plus f. Okay, where I is an integer and f is a fraction. A is a non-integer, say 6.2. 6.2 means what? 6 plus 0.2. Correct? There also I'll take cases there actually. F lies between 0 to half. I'll take f belongs to the interval 0 to half. Because there is 2a here, integral value of a minus integral value of 2a. Because of 2a, I'm separating this f as 0 to half one case. Another case I'll take f as half to 1, open interval. Fraction, f is a fraction. Fraction means a number between 0 and 1. Hope I understand. So I'll take a as I plus f because a is a non-integer. Suppose you take 6.2. 6.2 6 plus 0.2. 0.2 is a number between 0 and half. Correct? So in that case, what happens? This case, this I can call it a star actually. I'll be using this star. What is integral value of a now? A is I plus f. So this becomes integral value of I plus f minus integral value of 2 times a. 2i plus 2f. I'll get 2i plus 2f is equal to 7. And integral value of I plus f is I. Suppose integral value of 6.2, 6.2 is 6 plus 0.2. Correct? So integral value of 6.2 is 6. So integral value of I plus f is going to be I. Correct? And 2i plus 2f, what is integral value of that? See, f is a fraction between 0 and half, no? So 2f will lie between 0 and 1. Because f are taken in the interval 0 to half, 2f will lie between 0 and 1. Correct? Between 0 and 1, if this is a number, correct? It's a fraction. Correct? Integral value of that fraction is going to be 0. So integral value of 2i plus 2f will be 2i. I minus 2i is equal to 7. That means minus I is equal to 7. Or I is equal to minus 7. I'm getting. I is equal to minus 7. What is I actually? I is a minus f. Because a I took I plus f. I is a minus f. Correct? A minus f is equal to minus 7. Or a is equal to f minus 7. F is what? Between 0 and half. Since f lies between 0 and half, correct? F belongs to the interval 0 to half. I can conclude that f minus 7 will lie between 0 minus 7 is minus 7, correct? And half minus 7 is minus 6.5, correct? Minus 6.5. I'll get f minus 7. F minus 7 is nothing but a. So a is lying in the interval minus 7 to minus 6.5. I'm getting like this. This is a case where a is equal to I plus f and f is between 0 to half. Another case will arise where f lies between half and 1. Okay. In that case, I'll solve again the same type of. So if you solve that, what I'm going to get? A is equal to I plus f where f lies between half and 1. In that case, I'll discuss, can erase this part. I'll write here itself. Okay. I'll take a is equal to I plus f where f belongs to the interval half to 1. Okay. F is a fraction. So this part, this star referring to this equation star here, write down what is a, I plus f, correct? So integral value of I plus f minus integral value of 2a, 2 times I plus f, that is 2i plus 2f. 2i plus 2f is equal to 7. Integral value of I plus f is I only, correct? Because f is a fraction. F is between half and 1. You can take an example of 6.7 now or 6.8. 6.8 is 6 plus 0.8. Integral value of 6.8 is 6. So integral value of I plus f is I. 6 plus 0.8 is 6 integral value. And here, if you take 6.8, no, 2i plus 2f, that will be how much? In that case, integral value of 2i is 2i only. Integral value of 2f, f is between half and 1, so 2f will lie between 1 and 2, correct? If f belongs to the interval half to 1, where is 2f? 2f will lie in the interval 1 to 2, correct? 1 to 2, if you take an integral value of that, it is going to be 1. So this integral value of 2i plus f is going to be minus 2i minus 1 is equal to 7. And you got I minus 2i is minus I is equal to 7 plus 1, 8. So I is equal to minus 8. I is equal to minus 8. I is what actually? I is a minus f, correct? I is a minus f. A minus f equal to minus 8. So a is equal to f minus 8. Because f belongs to half to 1, f minus 8 belongs to what? Half minus 8 is minus 7.5 and 1 minus 8 is minus 7. Referring to this, f belongs to half to 1. So f minus 8 will belong to the interval. Therefore, I can write a belongs to the interval. Correct? Half minus 8 is minus 7.5. Correct? And 1 minus 8 is minus 7. Minus 7. So if we combine all these things, here we got a equal to minus 7, here we got a belongs to the open interval minus 7 to minus 6.5, and here we got a belongs to interval minus 7.5 to minus 7. Combining this and this, answer is a belongs to this interval minus 7.5 to minus 6.5. Option B is the answer. Or else you can verify using options also. That is another method we can do. Okay, little bit of different type of question asked on 24th of January, second shift 2023. Quite unusual question. This is on the property of greatest integer function and evaluating it and taking cases, because you need to find the value of a where it lies. Solutions given to you. Detailed solution is given here. Move on to the next one. Can you try this? Value of limit n tends to infinity. Can you simplify this expression? Look at the numerator. 1 plus 2 minus 3 plus 4 plus 5 minus 6, etc. 3n minus 2 plus 3n minus 1 minus 3n. I'll make some modification in the numerator so that I can simplify it easily. N tends to infinity is there. Numerator has to be simplified. Correct? I can write it as 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus etc. Last three terms are 3n minus 2 plus 3n minus 1 plus 3n. Okay, this entire thing I'll put it in one bracket, minus 2 times, see multiples of 3 are having negative sign, minus 3, minus 6, minus 9, like that. Rest non-multiples of 3 are positive, multiples of 3 are negative. That's observation. What I did is I added multiples of 3 in this bracket. Okay, actually I'm taking 1 plus 2, 4 plus 5, 7 plus 8. I am adding multiples of 3 to this bracket. To balance it, I have to subtract also, correct? So 2 times I wrote. Already multiples of 3 were present there with negative sign. That minus is kept out. And also I am subtracting multiples of 3, no? So 2 times 3 plus 6 plus etc. That is last term will be 3n. Like this. Divided by square root of 2n power 4 plus 4n plus 3 minus root of n power 4 plus 5n plus 4. Nice. We added multiples of 3 to this bracket. If I add something, I should subtract the same thing. So I subtracted the multiples of 3 and it becomes 2 times multiples of 3 because multiples of 3 are already present there, correct? Adding and subtracting multiples of 3, we get this, the numerator part I'm telling you. Add plus 3 plus 6 plus 9, subtract 3, 6, 9, etc. We get like this. Hope you understand this. Now this first bracket, terms inside this bracket, is sum of the first 3n natural numbers. Summation of 3n it is, correct? And here I can take 3 common there and it becomes summation of n it becomes after taking 3 out. This is equal to limit n tends to infinity. The first bracket is summation of 3n. Summation of 3n it is. Summation of 3n. Sum of the first 3n natural numbers. Not sum of the first n natural numbers. Sum of the first 3n natural numbers. Here you can take 3 common, no? 3 common is out. 3 is out. 3 comes out. 3 into 2, 6. Minus 6 times. What I get if 3 is taken out? 1 plus 2 plus 3 etc. That is summation of n. 6 times summation of n, correct? Divided by, denominator keep as it is, root of 2n power 4 plus 4n plus 3 minus root of n power 4 plus 5n plus 4. Like this we get. Okay. Now, summation of n, we know the formula, n into n plus 1 by 2. Summation of 3n is 3n into 3n plus 1 by 2. Correct? That's equal to limit n tends to infinity. Limit n tends to infinity. Summation of 3n is 3n into 3n plus 1 divided by 2. Minus 6 times. Summation of n is n into n plus 1 divided by 2. Divided by root of 2n power 4 plus 4n plus 3 minus root of n power 4 plus 5n plus 4. Almost we are done. See, look at the degree of numerator. Here I get n square, no? Highest power of n is 2. Here also I get n square. So, degree of numerator is 2, I can tell. Degree of denominator is not a polynomial actually. Degree of denominator is not a polynomial because there is square root there. Inside the square root there is a polynomial. Still I can consider this as I'm discussing the degree of numerator equal to degree of denominator. That concept can be applied here because n power 4 is there, no? If you take square root of n power 4, it becomes n square. I can tell that the highest power of n in the denominator is also 2. Correct? Numerator, highest power of n is 2. Denominator also, after taking square root, we get highest power of n as 2. If degree of numerator is equal to degree of denominator, limiting value as n tends to infinity, the limiting value will be the coefficient of n square in the numerator by coefficient of n square in denominator. Ratio of the leading coefficients we can tell. Ratio of the leading coefficients. Okay, already we done such kind of questions. Suppose if you want to give an example, limit n tends to infinity. Suppose I give an example like this: 3n square plus 5n plus 2 divided by say 8n square plus 6n plus 1. What is the limiting value for this? You see that numerator is polynomial of degree 2. Denominator is also polynomial of degree 2. Limit n tends to infinity is there. So what is the coefficient of n square in the numerator? 3. What is coefficient of n square in the denominator? 8. Answer is 3 by 8 for this. Correct? I'm just giving an example to understand. It's just an example for this. Same concept I'm going to apply here. Okay? Here n power 4, if you take square root, it is n square. So you just take the coefficient of n square in the numerator and coefficient of n square in the denominator. That will be the limiting value here. Okay? See here, if you multiply it, 3n into 3n is 9n square. What is coefficient of n square? 9. So 9 by 2. 9 by 2. Here you get n square, no? N square coefficient is 6 by 2. 6 by 2 is 3 or 6 by 2 only. Denominator, what is coefficient of n power 4? Of course, n power 4, if you take square, it becomes n square. What is its coefficient there? Root 2. Right? Root 2. Minus. Here n power 4 coefficient is 1. Correct? 9 by 2 minus 6 by 2 is 3 by 2. 3 by 2 divided by root 2 minus 1. Rationalize, multiply and divide by root 2 plus 1. You'll get the answer. Here a minus b into a plus b, a square minus b square. Correct? A minus b into a plus b is a square minus b square. Root 2 square minus 1 square. Denominator becomes 1. Root 2 square is 2. 2 minus 1 is 1. So what is the answer? 3 by 2 into root 2 plus 1. 3 by 2 into root 2 plus 1. Option B is the answer. Hope you understand this. Okay. Solution is given to you. Option B is the answer. Option B, 3 by 2 into root 2 plus 1. This is an example given just to understand purpose. Okay. It's not required. Move to the next one. Question number 10. X equal to 2 is a root of the equation x square plus px plus q equal to 0. X equal to 2 is a root of the equation. F of x is given like this. Want to find limit x tends to 2 plus of greatest integer value of f of x. Since x equal to 2 is a root, since x equal to 2 is a root of, x equal to 2 is a root of x square plus px plus q equal to 0, correct? I can substitute x equal to 2 satisfies because 2 is a root of, correct? So I can write 2 square plus x is to 2p plus q equal to 0. So what we have is 4 plus 2p plus q equal to 0. Keep it aside. I'll use that later. Now I have to find limit x tends to 2 plus of greatest integer value of f of x. First find limit x tends to 2 plus of f of x. Limit x tends to 2 plus of f of x. 2 plus means x not equal to 2p. X is slightly greater than 2p. So x not equal to 2p. Use the first line. What is the expression given there? 1 minus cos of x square minus 4px. And I can complete the square for this. q square plus 8q plus 16 is there, no? Look at this, q square plus 8q plus 16, we can complete the square there. What we have, q square plus 8q plus 4 square, correct? 8q is 2 into 4 into q, correct? This takes a square plus b square plus 2e, which is a plus b the whole square, q plus 4 the whole square, it is q plus 4 the whole square. These three terms, q square plus 8q plus 16, q plus 4 the whole square, I get q plus 4 the whole square. Whole thing is divided by what we have, x minus 2p to the power 4. And making use of this equation gives what? Q plus 4 is minus 2p, correct? Q plus 4 is equal to minus 2p. I can substitute. Q plus 4 is minus 2p. So this becomes limit x tends to 2p plus 1 minus cos of x square minus 4px plus q plus 4 is minus 2p. Minus 2p square is 4p square. Correct? Divided by x minus 2p whole to the power 4. Again, I can complete the square for this. This is nothing but x minus 2p the whole square, correct? 4p square is 2p the whole square, and this is 2 into 2px. So this takes a square minus 2ab plus b square, which is a minus b whole square. This is x minus 2p the whole square, correct? I'll write here. That's equal to limit x tends to 2p plus 1 minus cos of what we have, the terms inside the bracket, that is x minus 2p the whole square, and denominator x minus 2p power 4, write it as x minus 2p the square, as x tends to 2p plus x minus 2p is tending to 0 plus, correct? This angle is approaching 0, correct? This angle is what? X minus 2p the whole square. Square of that is present in the denominator, correct? I'm using this limit theta tends to 0. 1 minus cos theta by theta square is half. 1 minus cos theta divided by theta square is half. What angle is present here? Square of that is present in the denominator, correct? So like this, I'm using this. So as x tends to 2p plus, x minus 2p is tending to 0 plus. That means this angle is tending to 0. This angle is approaching 0, and we have square of this angle is present in the denominator. Angle present is x minus 2p the square. Square of that, which is x minus 2p square. So 1 minus cos theta by theta square. Exactly in this form. Answer is half. And they asked to find limit x tends to 2 plus f of x. Actually, the question asks is limit x tends to 2p plus of greatest integer value of f of x. I can write it as greatest integer value of limit x tends to 2p plus of f of x. Limit is taken inside, correct? Limit x tends to 2p plus of this f of x, we got it as half. Entire thing we got and simplified. Integral value of half, which is equal to 0. Answer is option D. Question asked on 29th of January, 1st shift, 2023. Hope you understand this. Linking the limits with quadratic equation and getting the answer. Move on to the next one. Question number 11. Solution is given to you here. Detailed solution. 11th one. F, G and H be the real valued functions defined on R. F of x given like this, G of x and H of x all are given. Want to find limit x tends to 1 of G of H of x minus 1. Three functions are given to you, F, G and H. And want to find limit x tends to 1 of that composite function, G of H of x minus 1. G of H of x minus 1. Okay. And because it involves the greatest integer function and the modulus function, I need to find out the left hand limit and right hand limit separately. Already discussed many times. Whenever the given function involves the modulus function, greatest integer function, fractional part function, or signum function, and square root function, when the function is defined in piecewise, there are two pieces or three pieces, in that case we find out the left hand limit and right hand limit separately, because we do not know limit exists or not. So we need to find out left hand limit and right hand limit separately here. Okay, left hand limit will go first. Left hand limit. Limit x tends to 1 minus. Limit x tends to 1 minus. What is the function? G of h of x minus 1. X tends to 1 minus means what? X is slightly less than 1, correct? So put x equal to 1 minus h, but h is already used as a function. I'll use 1 minus k here, okay? Put x equal to 1 minus k, where k is some positive quantity. Put x equal to 1 minus k, where k tends to 0. Where k tends to 0. 0 means 0 plus, it's understandable. 0 means 0 plus, slightly greater than 0, not 0 minus. It's understandable. I won't write that, 0 plus. Limit x tends to 1 minus, the same as k tends to 0. K tends to 0, g of h of, what is x? X is 1 minus k. 1 minus k minus 1, like this I get. In place of x, you put 1 minus k. 1 minus 1 becomes 0 there. So what we get? Limit k tends to 0, k tends to 0, g of h of 1 minus 1 will add up to 0, h of minus k. What is h of minus k? H of x is given here. Use that. That is equal to limit k tends to 0, g of, what is h of minus k? H of x is given here. H of minus k means you replace x by minus k. 2 times integral value of minus k minus f of x. That is, f of x is what? F of x for k tends to 0. That means f of x is x by mod x, correct? I am putting h of minus k. H of minus k means I am putting x as minus k. F of minus k becomes f of minus k here. F of minus k. That is equal to limit k tends to 0, correct, g of integral value of minus k. K is tending to 0. Say k equal to small positive quantity 0.1. Integral value of minus 0.1 it becomes. Integral value of minus 0.1 is minus 1. 2 into minus 1 is minus 2 here. And f of minus k is what? F of minus k, where k is almost 0 but not equal to 0. So not equal to 0 means I'd use the first line, x by mod x. F of minus k will be f of minus k is minus k by mod of minus k. Correct? F of minus k is minus k divided by mod of minus k. This is becoming what? This is equal to limit k tends to 0. I'll write here itself. Limit k tends to 0, g of minus 2, minus of minus k is plus k, mod of minus k is same as mod k is k because k is positive, so it becomes minus of minus plus k by k 1, so g of minus 1 becomes limit k tends to 0, which is no more limit exists because I am applying the limit, no, so limit is not there at this stage because you are applying the limit at this stage. Here limit is not there. G of minus 1, g of, it becomes minus 1 at this stage, right? Is equal to g of minus 1. What is g of minus 1? G, at x equal to minus 1, g is defined to be equal to 1. So g of minus 1 is 1. Hope you understand this. This is left hand limit. Now I should find out the right hand limit. Right hand limit is limit x tends to 1 plus, slightly greater than 1. We'll find out the right hand limit now. Right hand limit. Limit x tends to 1 plus. Limit x tends to 1 plus of g of h of x minus 1. X tends to 1 plus means what? X is slightly greater than 1. So put x equal to 1 plus k. Put x equal to 1 plus k, where k is small positive quantity, where k is tending to 0. Where k tends to 0. So that's equal to what? Limit, instead of x tends to 1 plus, I'll put k tends to 0, okay, g of h of, put x as 1 plus k, whereas wherever there is x you put 1 plus k minus 1, plus 1 minus 1 will cancel. What do you get? Limit k tends to 0, limit k tends to 0, g of h of k, correct? What is h of k? H of k is here, h of x is given. Now from there you can write h of k, that's equal to limit k tends to 0, limit k tends to 0, g of h of k. H of k is 2 into integral value of k. 2 into integral value of k minus f of k. Correct? Integral value of k. K is very close to 0. Say k equal to 0.1. Integral value of 0.1 is 0. This part is gone. 0. 2 into 0, 0. F of k. K is what? F of k is k by mod k. Mod k is k because k is positive. K by k is 1. Correct? I'll write here the remaining part. I'll write here, this is equal to limit k tends to 0, limit k tends to 0, what we have, g of 0, this part is 0, f of k is what, k divided by mod k, because k is close to 0, no? K is close to 0 means k is not equal to 0. If a number is not equal to 0, the function to be used is x by mod x. So f of k is k by mod k. Mod k is k, so k by k is 1. This becomes 1. So that means this becomes g of minus 1. G of minus 1 is out. At x equal to minus 1, g is defined to be equal to 1. Left hand limit is 1, right hand limit is also 1. Both are equal, hence limiting value is 1. Option E is the answer. Hope I understand this. Move on to the next one. Solution is given to you. Left hand limit and right hand limit. Question number 12, the last one I think in this. Here limit x tends to infinity is there. See, numerator root of 3x is there, no? Root x is there, I can tell. Root x power 6 will be x cube. Here also root x power 6 will be x cube. Numerator I can tell the power of x is 3. Highest power of x is 3 in the numerator. That x cube into x cube will become x power 6. Correct? Denominator, the highest power of x is 6. I can tell numerator and denominator are both having highest power of x as 6. Correct? So I can use limiting value is x tends to infinity. Limiting value is nothing but the ratio of the leading coefficient. Coefficient of highest power of x in the numerator to coefficient of highest power of x in denominator. That will give the answer. Correct? So, because there is root of x now, root of 3x plus 1, I can tell root x is there. Root x power 6 is x cube. Correct? Here also I get x cube. That x cube into one more x cube is given here. That will make x power 6. X cube into x cube will become x power 6. Denominator is already x power 6 present. Correct? So, you just take the coefficient of highest power of x in the numerator and coefficient of highest power of x in denominator. That will give the answer. If you are doing the actual method also, you can do it by taking common. I'll show the solution later. So you look at this, as x tends to infinity, what is coefficient of x here? Root 3, correct? Limiting value is root 3. Here coefficient of x is root 3, correct? Root 3 plus root 3 to the power 6, correct? Plus here coefficient of x is root 3 here, inside the root I'm telling. I'm taking the coefficient of root x here, inside the x power half, because the x power half power 6 will give x cube. So coefficient of x is 3 there, root 3, inside the root. Inside the root, coefficient of x is root 3, correct? Root of 3 to the power 6. X cube will become x power 6. Denominator, what is coefficient of x? 1 there, correct? 1 power 6. And here x square is there, no? Root of x square is x. Root of x square is x power 6. Here also you get x power 6, here also you get x power 6. So coefficient of x power 6 is 1 plus 1. Here to the power 6 is there. Plus here coefficient of x is 1. Here coefficient of root of x square, nothing but coefficient of x 1 to the power 6 over answer. This is equal to root 3 plus root 3 is 2 root 3 to the power 6. And this is 0 divided by 1 plus 1, 2 power 6 plus 0. Correct? This is 2 power 6 into root 3 power 6. Root 3 power 6 is 3 cube divided by 2 power 6. 2 power 6 is going to cancel. 3 cube is 27. Answer is done. Within 10 seconds you can get the answer. Hope you understand. If you want the actual method, I'll show you. That's the actual method. Taking out x common from this, balance it by dividing by x. X into 3 plus 1 by x. X into 3 minus 1 by x. Same story here. And here x is taken out, x power 6. 1 plus root of 1 minus 1 by x square, like this. And as x tends to infinity, 1 by x tends to 0. 1 by x square tends to 0. All those things will become 0. This all becomes 0 here. Correct? Then x cube into x cube is x power 6 will cancel. Root of 3 plus 0. Root of 3 minus 0 whole power 6. 3 plus 0. 3 minus 0 power 6. Correct? 1 plus root of 1 minus 0 plus root of plus 1 minus root of 1 minus 0. Get the answer as 27 like this. Taking out highest power of x out, and as x tends to infinity, 1 by x tends to 0. Such kind of simplification is done. Okay. With this we completed the 2023 PYQs of JEE Main. This is preparing. You can prepare properly if you listen to our classes. learn the synopsis properly, write and study all the formulas. Mathematics is a subject based on the formulas and equations. That only you have to study first. If you're not studying the formulas and equations and directly jump to working on the problems, it's of no use. First study the formulas and equations, whatever we have, the concepts, results, all thoroughly. Write and study all the formulas, okay? And after learning, you try to write on your own. Prepare a notes of your own. Limits, what all different concepts are there in limits. Start with basics, algebra of limits, indeterminate forms, how to evaluate limit by direct substitution, by rationalization, by factorization, then come to L'Hopital's rule, then sandwich theorem, limits of trigonometric functions, limits of exponential and logarithmic function, then Newton-Leibniz formula, series expansion, like that. One by one, you study all the formulas thoroughly, all the formulas and concepts of limits, then work out the problems. Till now we have done 2019, 2020, 2021, 2022, and also we completed just now 2023 JEE Main questions, appeared questions. Okay, in the next session I'll be doing 2024 appeared questions of JEE exam, and next month 2025 as well. Then also before 2019, whatever we had, no, it was not conducted by NTA, and we didn't have many strips. They're conducting the JEE exams for both online and offline. It was optional for students, and we don't have many papers like now. In 2019 they conducted so many strips, 2020 they conducted so many strips, correct? Like that we didn't have, only one exam or one or two exams for that. Even those questions also we'll discuss in one session. And then I'll go to continuity. Okay, continuity of a function, slightly climbing up. Continuity means graphically the function has no break or no jump or no whole interval. Okay, then theoretically we'll find out what is continuity of a function. Left hand limit should be equal to right hand limit equal to the function value. And what about the types of discontinuity of a function, and work out the problems connected to continuity. Then go to differentiability. Okay, then we'll go to methods of differentiation. Various methods of differentiation are there, very interesting methods. Then go to application of derivatives, like that. One by one we'll cover, okay, all the previous year questions. And also, if possible, if time is there, I'll work out other questions also which is not appeared in the exam till now, which is important, which seems to appear in the upcoming years. Such kind of questions also we should work out. Okay, with this I'll conclude. Thank you.